The heat index or humiture or humidex is an index that combines air temperature and relative humidity in an attempt to determine the human perceived equivalent temperature how hot it feels. The result is also known as the felt air temperature, or apparent temperature. For example, when the temperature is 32 degrees Celsius with very high humidity, the heat index can be about 41 degrees Celsius. The human body normally cools itself by perspiration, or sweating. Heat is removed from the body by evaporation of that sweat. However, relative humidity reduces the evaporation rate because the higher vapor content of the surrounding air does not allow the maximum amount of evaporation from the body to occur. This results in a lower rate of heat removal from the body, hence the sensation of being overheated. This effect is subjective. Its measurement has been based on subjective descriptions of how hot subjects feel for a given temperature and humidity. This results in a heat index that relates one combination of temperature and humidity to another. History: the heat index was developed in 1978 by George Winterling as the humiture, and was adopted by the USA's National Weather Service a year later. It is derived from work carried out by Robert G. Stedman. Like the wind-chill index, the heat index contains assumptions about the human body mass and height, clothing, amount of physical activity, thickness of blood, sunlight and ultraviolet radiation exposure, and the wind speed. Significant deviations from these will result in heat index values which do not accurately reflect the perceived temperature. In Canada, the similar humidex is used in place of the heat index. While both the humidex and the heat index are calculated using dew point, the humidex uses a dew point of 45 degree Fahrenheit as a base, whereas the heat index uses a dew point base of 57 degree Fahrenheit. Further, the heat index uses heat balance equations which account for many variables other than vapor pressure, which is used exclusively in the humidex calculation. A joint committee formed by the United States and Canada to resolve differences has since been disbanded. The heat index is defined so as to equal the actual air temperature when the partial pressure of water vapor is equal to a baseline value of 1.6 kilopascals. At standard atmospheric pressure, this baseline corresponds to a dew point of 14 degrees Celsius and a mixing ratio of 0.01. This corresponds to an air temperature of 25 degrees Celsius and relative humidity of 50% in the sea level psychrometric chart. A given value of relative humidity causes larger increases in the heat index at higher temperatures. For example, at approximately 27 degrees Celsius, the heat index will agree with the actual temperature if the relative humidity is 45%, but at about 43 degrees Celsius, any relative humidity reading above 17% will make the heat index higher than 43 degrees Celsius. The formula described is valid only if the temperature is 27 degrees Celsius or more, and the relative humidity is 40% or more. The heat index and humidex figures are based on temperature measurements taken in the shade and not the sun, so extra care must be taken while in the sun. The heat index also does not factor in the effects of wind, which lowers the apparent temperature, unless the air is above body temperature. Sometimes the heat index and the wind chill are denoted collectively by the single term apparent temperature, relative outdoor temperature, or feels like. Meteorological considerations: outdoors in open conditions, as the relative humidity increases, first haze and ultimately a thicker cloud cover develops, reducing the amount of direct sunlight reaching the surface. Thus, there is an inverse relationship between maximum potential temperature and maximum potential relative humidity. Because of this factor, it was once believed that the highest heat index reading actually attainable anywhere on Earth is approximately 71 degrees Celsius. However, in Dhahran, Saudi Arabia on July 8, 2003, the dew point was 35 degrees Celsius while the temperature was 42 degrees Celsius, resulting in a heat index of 78 degrees Celsius. This is comparable to the temperatures that are recommended to kill bacteria in many meat products, and it is common in a sauna. Table of heat index values. This table is from the U.S. National Oceanic and Atmospheric Administration. To find the heat index temperature, look at the heat index chart above. For example, if the air temperature is 96 degree Fahrenheit and the relative humidity is 65%, the heat index euro, how hot it feels euro is 121 degree Fahrenheit. This table is an approximation of the heat index, using the formula and first set of constants below, converted to Celsius. Effects of the heat index. Exposure to full sunshine can increase heat index values by up to 8 degrees Celsius. Formula. The formula below approximates the heat index in degrees Fahrenheit, to within a plus or minus 1.3 degree Fahrenheit. It is the result of a multivariate fit to a model of the human body. This equation reproduces the above NOAA National Weather Service table, where equals heat index equals ambient dry bulb temperature equals relative humidity. An alternative set of constants for this equation that is within 3 degrees of the NWS master table for all humidities from 0 to 80% and all temperatures between 70 and 115 AA degree Fahrenheit and all heat indexes of 150 AA degree Fahrenheit is. A further alternate is this, where, for example, using this last formula, with temperature 90 AA degree Fahrenheit and relative humidity of 85%, the result would be, heat index for 90 degree Fahrenheit, RH 85% equals A 114.9. See also, apparent temperature, humidex, wind chill, references. External links, description of wind chill and apparent temperature formulae in metric units. Heat index calculator calculates both a degree Fahrenheit and a degree Celsius.